Hello. This lecture video will talk about organization of the body. So when we look at how our body is organized, we started out talking about cells, and then we looked at the different tissues that make up the body. And those tissues, groups of tissues with a similar function, make up organs. And then different organs working together, like the blood vessels and the heart working together, make up an organ system, which we would call the cardiovascular system. So when we look at these organ systems, there's some basic components and parts that you should be familiar with. First of all of our organs and organ systems are housed within body cavities. And those body cavities can be divided into some general regions. So if we look at a side view of the body here, this first slide is showing the back side, the brain, the cranial cavity, and the vertebral cavity. That's part of the dorsal cavity. So it's found on the back side of the body. And on the front side of the body are the different cavities that house a lot of different organs. This is the ventral cavity. All of these together we call the ventral cavity. So two real general terms is the dorsal cavity and the ventral cavity, and those are further broken down. So the dorsal cavity, we said, is the cranial cavity that contains the brain. The vertebral cavity contains the spinal cord, because that nervous tissue is really, really delicate. So this cavity is really housed completely by bone to protect that precious brain and spinal cord. The ventral cavity contains a lot of the organ systems that we're going to go through this semester outside of the nervous system. So we have the thoracic cavity, which houses the respiratory system, the cardiovascular system, parts of the digestive system like the esophagus. That is found in the thoracic cavity. So it's above the diaphragm. That's that muscle of tissue that raises and lowers to allow for breathing. So when we go below the diaphragm, we have the abdominal cavity, which contains our digestive organs. And then we have the pelvic cavity that contains the reproductive organs. And then there's another cavity kind of behind the abdominal cavity. It's called the retroperitoneal cavity, and that's where we find the kidneys. But we're not going to talk about that cavity. We're going to focus on the abdominal cavity, which is all those digestive organs, and the pelvic cavity. And if we think about which cavity is least protected, it's definitely the abdominal cavity and the pelvic cavity, because there's no bone surrounding that cavity completely. The thoracic cavity is protected by the ribs, so we get a little protection to those lungs and heart because of the ribs and the sternum. But we don't see that in the abdominal cavity. So when people are injured in car accidents and motorcycle accidents, it's oftentimes the abdominal organs that are severely damaged, and the kidneys. So looking in the front, in the thoracic cavity, we have a membrane around each of these cavities, which we call the pleura. So the pleura surround the lungs, and the pericardium is the membrane around the cavity of the heart. So in the thoracic cavity, we have two different membranes. The pleural membrane surround the lungs, and the pericardial membrane, or the pericardium, is the membrane around the heart. So these body cavities are lined with membranes to house the organs in that cavity, keep them in place, and also provide a low friction environment, because there's a membrane around the organs and a membrane around the cavity, and between those membranes is a thin amount of fluid. So we call it pleural fluid, pericardial fluid. If we're referring to the lungs, pleural fluid is between the two membranes, the one covering the lungs and the one lining the cavity, called pleural fluid between those membranes, and then pericardial fluid between the membrane that lies over the heart and the membrane that lines the cavity around the heart. So the membrane around the abdominal organs, the digestive organs, we call that the peritoneum. Again, the membrane lining that cavity. And we don't really have a special membrane for the organs that are found in the pelvic cavity, like the bladder and the reproductive organs. So these membranes line the cavities and they line the organs. So we have different types of body membranes depending on where they're found. So we'll talk about these. The mucous membranes line the inside of your digestive tract. They line the urinary tract, the reproductive tract, the respiratory tract. They secrete mucus. They provide a purpose of trapping debris or helping move things through. Regardless, mucous membranes line those hollow tubular structures. And the goblet cells are the special cells that secrete mucus into the surface of these organs. Serous membranes, those are the ones that line the cavities. Like I said, we have the pleural membrane that lines the thoracic cavity and covers the lungs. We have the pericardium that lines the cavity around the heart and covers the heart. And the peritoneum lines the abdominal cavity and covers all those abdominal organs. Synovial membranes are membranes we find at joints. So these membranes line the space between joints, and they're filled with a fluid called synovial fluid that helps keep our joints healthy and moving. So as long as we're getting a decent amount of activity, that helps promote synovial fluid and helps lubricate our joints. However, when we don't exercise and we spend a lot of time sitting, that causes low synovial fluid production, and people tend to get achy, kind of stiff joints. So it's really important that we keep moving, that we get mild exercise, either with some brisk walking or light jogging, bicycle riding. Anything that gets those joints moving is going to promote the production of synovial fluid. When people start to get knee trouble, they tend to not want to exercise, and that actually makes their knees worse. So anybody with arthritis needs to get those joints moving to get that synovial fluid production and to slow the damage to the joints. Not moving and having a sedentary lifestyle actually damages joints and promotes arthritis and can help advance the disease and make it worse over time. So it's really, really important that people move when they have joint issues. The meninges, these are special membranes that line the vertebral cavity around the brain and spinal cord. It helps protect damage to those delicate organs. And if we have an infection, like from a bacteria or a virus, that is what causes meningitis. So anytime someone complains of a stiff neck, severe headache, they need to be seen because those are classic signs of viral or bacterial meningitis. So when you talk about how these different body systems work together to maintain a pretty stable environment, we call that homeostasis, and that's when all systems are working correctly. We have a normal body temperature, we're not dehydrated, the heart rate is just at a normal resting level, or even if we're exercising, it's appropriate with the level of exercise. Everything is just about the way it should be. We call that homeostasis, and all of our body systems work together to maintain that. And the lack of homeostasis is what brings people to the hospital. So the internal environment is the fluid in which all this metabolism occurs and where homeostasis is maintained. So the internal environment refers to our blood and the interstitial fluid, which is the fluid between our cells. And we also have fluid inside of our cells. So all of this fluid throughout the body is constantly maintained to keep homeostasis. So we're delivering oxygen, picking up carbon dioxide, we're delivering nutrients, we're picking up wastes. We're always working to maintain this homeostasis. So key controllers of homeostasis are the nervous and endocrine system. The nervous system is really good at responding to changes. For example, if you see something that looks dangerous, the nervous system is going to kick off the fight or flight response and cause you to respond to it to maintain safety. For example, if you see your child is going to run in front of a car, you're going to quickly run and save that child, and you're going to activate your muscles and your eyesight to respond quickly. If you burn yourself, if you touch something hot, your nervous system pulls that arm away before you're even aware of it. It's a reflex. So that nervous system is very quick and very good for reflex activity. The endocrine system is going to secrete things to maintain overall homeostasis and acts a little slower. For example, when you eat a sandwich, your blood sugar goes up. As you break down that sandwich and that sugar is released to your blood, the endocrine system is going to respond by secreting insulin from the pancreas, and that's going to lower your blood sugar. So that's a slower acting system for homeostasis, but it's still very important because if we don't lower blood sugar, that'll eventually do damage to the body. And that's why diabetics really need to control their blood sugar, because it'll damage their blood vessels, it'll damage their small nerves, and they end up with kidney failure, loss of eyesight, and they see damage to their feet as the skin breaks down and doesn't heal, and then they end up losing their lower legs, like from the knee down. So really, really important that we maintain this homeostasis. The most common type of homeostatic control is the negative feedback control. And this is something that if some variable in the body is out of control, the body systems kick in and they bring that variable back under control again. For example, like your furnace. When the temperature in your home gets too cold, the furnace kicks in, heats up the temperature, and then the furnace kicks off. That's how our body works. When blood sugar goes high, the body kicks in, releases insulin, and blood sugar goes down. That's called negative feedback. When you hear the word negative, you think of something negative, right? But that's not the truth. What negative feedback does, it just acts in a direction that is opposite of the variable. For example, if something is getting too high, like blood pressure, the body kicks in and the blood pressure goes down. But if something is too low, like blood pressure, the body kicks in and blood pressure goes up. So again, it's the nervous system and the endocrine system that are the control centers for sending a stimulus to the different organs to either bring those variables up or down. For example, let's say it's really cold. Let's say the temperature is rising. So that stimulus is picked up by sensory receptors in the skin. So that would be the sensor that's sent to the hypothalamus in the brain, the nervous system. And the nervous system says, okay, temperature is getting too cold. So we're going to activate the muscles. So it's going to stimulate the muscles, the effect to shiver, to raise body temperature and get us back within that normal temperature range of homeostasis. So every negative feedback system has a sensor, which is part of the nervous system, picking up information that some variable is not correct. That information is sent to either the nervous system or the endocrine system or both. And then that response goes to an organ that's going to bring it back under control. For example, blood sugar. Blood sugar is going to be brought back under control by the pancreas. The pancreas is going to secrete insulin, and it's going to lower that blood sugar and get us back to homeostasis. So that's a negative feedback mechanism. And here's an example using the temperature in your house. So the sensor would be the wall thermostat. And once it reaches whatever you have your setting at, the control center, if it's below what you have as the set point, then that's going to kick in the furnace or turn off the furnace if it's getting too warm, and that's going to bring the room temperature back under control. So here we have an example of a thermostat that is showing that it's getting too hot, and this bottom example is when it's getting too cold. So either way, you have a sensor, which is your wall thermostat. The control center is set by whatever you have the setting on the thermostat, and then your effector, or what's going to cause a change in the room temperature, that's the furnace. So same thing as with body temperature, like we already talked about, using the skin and the brain. But there's another type of feedback called positive feedback. And positive feedback doesn't bring things back to normal, but what it does is it kicks in a response to accomplish something in the body. For example, when the baby's head is pushing against the cervix, that causes oxytocin release, which causes more contractions of the uterus, which causes that baby to press against the cervix more. So it's actually enhancing the change, but the goal is to get the baby to be born. So this is not acting opposite of the variable. It's acting in the same direction, but it's achieving some goal, which is, again, getting the baby born. We see positive feedback when a mother is nursing her baby. The suckling of the baby on the breast causes milk release. And the more baby suckles, the more the milk is released. Again, it's acting in the same direction. It's enhancing milk release, but the goal is to feed the baby. And when the baby is full, the baby stops suckling at the breast, and then milk letdown discontinues. So there's a goal with positive feedback, but it's not to maintain homeostasis. So that concludes our discussion about homeostasis. Your next video is one that you can watch on YouTube talking about the different types of body tissues.